Hi, Algebra 2 students. This is Miss Lewinsky again, and I will be doing the videos for topic number 4, which is about rational functions. Today we begin with looking at section 4.1, which is about inverse variation and the reciprocal function. You can see that the objective is I can use inverse variation and graph translations of the reciprocal function. And we'll be doing this for the next couple of days. Before we begin, I want to look at this model and discuss from the Pearson curriculum. It says there's two rectangles shown below, and they both have an area of 144 square units. Remember, area is length times width. Part A wants you to sketch as many other rectangles as you can that have the same area. Organize and record your data for the lengths and widths of each rectangle. So pause the video and take a second and see how many rectangles you can make. Okay, so what I did is I started making a table. And if I made one side length of 1, it would be 1 by 144. So 144. They already had 2 and 72. 3 does not work. Oh, 3 does work, sorry. 3 by 48 is what I got. So if I drew the picture, it would look like that. Obviously, these aren't to scale. This will be much longer. 4 works. 144 divided by 4 is 12. 5 didn't work. 6 was 24. I'm not going to draw pictures anymore. I'm just going to keep going. 7 did, oh, yep, 6 was right here. 7 didn't work. 8 and 18. 9 and 16. And 12 and 12. These are all my possible ways to get a product of 144. So meaning if I multiply them together, I get 144. So part B says considering rectangles with an area of 144 square units, what happens to the width of the rectangle as the length increases? So when we look at my table, the length is increasing over here, and we can see that as these are increasing, the width is actually decreasing. So as one's going up, the other goes down. We'll skip part C, but this idea, this relationship of one thing going up and the other going down is what we're going to focus on in this section. Before we get too far, we are going to look at some key vocabulary. The first is going to be inverse variation. I do want you to write this down. Inverse variation is a relation between two variables such that as one variable increases, the other decreases proportionally. So once again, a relation between two variables such that as one increases, the other decreases. But a huge important word is proportionally. Okay, so we'll talk about what that means as time goes on. But they can't just have one going up, one going down. The key is that for a table to represent inverse variation, the product, remember that's multiply, the product of x and y must be constant. So if we think back to the warm-up that we just did talking about the rectangles with an area of 144, we said that as the length increased, the width decreased, so that fit this idea, whereas one increases, the other decreases. But that proportionally thing is what we're talking about here. It's because every time we multiplied the length times width in that case, we got 144. That means it was an inverse variation. So to start here, we're just going to look at a few different tables and decide if they have an inverse variation. Okay, so does the table of values represent an inverse variation? So again, I would get a couple of these in my notes if I was you. You don't need all of them necessarily. But what I do when I'm looking at this is I look at my x values and I see 1, 2, 3, 4, 6, 12. Those are going up. The y's, 12, 6, 4, 3, 2, 1, those are going down. So they have that first part, whereas one increases, the other decreases. But that's not enough to decide its inverse variation. Now I need to find the product of x times y. A lot of times with the table, we'll just put that right below. So I'm going to multiply 1 times 12, which is 12. 2 times 6, 12. 12, 12, 12, and 12. And because all of these are the same, then yes, it is an inverse variation because all those things are the same. Okay, let's look at the next one. 1, 2, 3, 4, 5, 6. The x's are increasing. 20, 17, 14, 11, 8, 5. Those are decreasing. So I can do my next step to confirm or see if they are in fact inverse variation. 20 times 1 is 20. 17 times 2 is 34. I actually could stop right there because these two are different. So even though x is going up and y is going down, this is not inverse variation. Okay? You could keep going. You wouldn't have to, but if I multiply these, I'd get 42, 44, 40, and 30. So we can see that none of them are the same. But again, as soon as I got two that were different, it's not inverse variation. I want you to pause the video and look at these two tables. It's okay that you have decimals. You might need a calculator now, but I want you to follow the same process and decide if these tables represent an inverse variation. Hopefully you got that the first one was yes again, and the second one was no. In both cases, the variables were going opposite directions, so that was good. One was going up, one was going down. But when we look at the first table, all of these, the product of x and y was 25.5, and in the second, the first product was 19.8, and the second was 27.5, so I stopped there and said no. Okay, so the first thing we're going to have to do is be able to decide if a table represents inverse variation. The next thing we're going to do is find this thing called the constant of variation. So get this written in your notes as well. The constant of variation is going to be represented by the k, and it is the number that relates the two variables in an inverse variation. Okay, the reality is it's what you get when you do x times y. Okay, so if I ask you to find the constant of variation and you're given the table, you would just do the x times y and figure it out. And you can see in this one it tells us the constant of variation is 24, but again, it's because when I multiply every column together, I get 24. So it's this row that we were finding before that has the special term called the constant of variation. And that's going to be represented by k. Now, here's a quick side note that we're going to use in the future examples. So what this is saying is that x times y equals k. Right? So if you're ever asked just to find the constant of variation, you can just do x times y. Sometimes you're going to be asked to write an equation or a function for an inverse variation. We typically like to have equations set equal to y. So if I wanted to solve this for y, I would just divide both sides by x. So the equation for an inverse variation is usually written as y equals k over x. Okay, and in the next few examples, we're going to talk about how we can solve for future values in an inverse variation. Here's example 2. It says in an inverse variation, x equals 10 and y equals 3. Write an equation that represents the inverse variation, then find the value of k when y equals find the value of y when x equals negative 6. Again, what we just looked at is that ultimately we're going to be using y equals k over x. And now again, because we know x is negative 6, we're going to plug that in. The problem is we can't do that until we know what k is. Okay, so once we know what k is, then we can solve this question. Well, if they give me an x and a y, we know that k is just that x times y. So my k is going to be 10 times 3, k is 30. So now I'm going to take this equation and put 30 over my x, which is negative 6. So y is negative 5. Okay, so when x equals negative 6, y equals negative 5 is my answer. Now, just so you know, sometimes you would take the y equals k over x, and you would do 2 steps of substitution. First, you would put 3 in for y, 10 in for x, but you can see that if we do that, then we would multiply both sides by 10, and we still get that 30 equals k, which we then plugged in. Okay, so whether you like to just find k first by multiplying the x and y, or plug it into that eventual function or equation and solve for k, either way is fine. You're ultimately just multiplying. Okay, I want you to try this one on your own. First, write what is the equation that represents the inverse variation, which means I want you to find k and plug it in. Okay, so and that's going to be important because in Pearson it asks you to do that. So you're going to find k and plug it in, but your answer will have an x and a y in it, just so you know. And then step 2 is if I'm telling you x is 15, what would y be? So Pearson does ask you to do problems this way, so they're asking you to do it in 2 steps. So pause the video and try it on your own. Hopefully for this first one, you knew you had to find k, which again is x times y, so 6 times 1/2, and you got 3. So the answer when it asks you just for that equation is just y equals 3 over x. And then it says, what is the value of y when x equals 15? Take that 3 over instead of x. I'm going to put 15. Make sure you simplify. That would be 1. Y equals 1/5. Okay? So you can either write that, or if we wanted to write it as a whole sentence, when x equals 15, y equals 1/5. Either way for now. All right, we can also use this in some real-world application and word problems. This one says, on a guitar, the string length S varies inversely with the frequency F of its vibrations. Okay, so now it's important that we understand this language. If S varies inversely with the frequency of its vibrations, that means S equals K over F. Okay, so whatever varies inversely comes on the left-hand side of the equation. Okay, when we go down to the bottom, it says the frequency of a 26-inch string, that is the S, that's the length, right, is 329.63 cycles per second. That's the frequency. So that is one pair. And then it wants to know what is the frequency, so it wants to know what's F when the string length is 13. Okay, so I'm going to use this function up here that we've got, but first we always need to find that K. In order to find the K, I'm going to use these 2 pieces of information, and I'm going to show you how I could do it here. I can just plug in 26 for S, K over 329.63. Multiply both sides by that. Type it in my calculator, and I got K is going to be 8,570.38. That's the constant, which means it's always that. So now I can rewrite my equation with that in place of K. Now I could use this to identify the frequency for any string length or the string length for any frequency. In this case, though, they do tell me that the string length is 13, so they actually give me this. This is going to take just a little bit different algebra. We have to make sure we go in order. A lot of people would make mistakes here. You must first multiply both sides by F. So I have 13F equals 8,570.38, and then I would divide by 13. So it's actually 2 steps in this case. And I get that the frequency is 659.26, and it's labeled in cycles per second. I know that because that's what they used in the problem. So that is my frequency. All right, I want you to take a minute, read this problem, and see if you can do this one on your own. So pause the video and see how you do. All right, hopefully, as you did this, you saw that time, I decided to call time T. So the amount of time it takes for an ice cube to melt varies inversely, so that's why it's T equals K over with the air temperature. So I called air temperature A. So I need to understand that's the case. At 20 degrees Celsius, the ice will melt in 20 minutes. I don't love that they use 20 both times, but after 20 minutes, so this 20 was the T, and then 20 degrees was right here. Okay, so divided by 20 degrees Celsius, that was the A. I multiplied both sides by 20, and I got 400 equals K. So my equation I can keep using is T equals 400 over A, and they specifically wanted me to figure out how long it will take to melt it if the temperature is 30 degrees. So I did 400 divided by 30, and I got 13.3 minutes. Okay, that's section 4.1, day 1, introducing this inverse variation idea and writing equations and using them. So you can now go to your Pearson practice for section 4.1, day 1. Thank you.